Hello everyone, so let's solve the problem capacity to ship packages within D days. What is the problem saying? A conveyor belt has packages that must be shipped from one port to another within days. Alright. The ith package on the conveyor belt has a weight of this. Each day we load the ship with packages on the conveyor belt in the order given by weights. We may not load more than the maximum weight capacity of the ship. Return the least weight capacity of the ship that will result in all the packages on the conveyor belt being shipped within the days. So what are we given? We are given an array of weight of each package, let's say this, and a number of days, let's say this. Now what is our task? Our task is to choose a capacity of ship, let's say X. Choose in such a way that this X will be minimum and all these packages can be loaded into that ship one by one, and they can be shipped. All these packages can be shipped within this number of days. Okay, there can be more than one ship. Okay, so that is our task. Let's say we choose a capacity of 2, let's say. So let's try to load our package. We can load this one in this ship, right? But we can't load this one, right? So we need to increase our capacity. Let's say 3. We can load this, but we can load this, but we can't load this one. Similarly, if we choose 4 as our capacity, we will be able to load these 3, but not this one. So we can see that our ship have to have a minimum capacity of the maximum weight present in out of all the packages, that is 6. This one, let's say we choose a capacity of 6, we will be able to load all of them, isn't it? So let's try to load our packages one by one. This is our capacity. 6 is our ship capacity. Can we load 2? Yes, we can load. Can we load 3? Yes, we can load. What is the capacity? 5. Can we load 4 with that? No. 5 plus 4 is 9. We exceed our capacity. So this takes one ship. Fine. Okay. Now let's start afresh. Let's load this one. Okay. Let's load this one. No, it exceeds. We can load this one only in one ship. Okay. How many ships did we take so far? 2. Now let's try to load this. It's 5. Can we load this one? No. We take one more ship. Then we take this one and we load it in another ship. So how many ships did we require? We required 2 plus 1 plus 1, that is 4 ships. And as per the question, each of these ships will be shipped in each day. The first ship will be shipped in the first day, the second one in second day, the third one in third day, the fourth one in fourth day. But we have been given this, that we need to finish our shipping within 3 days, but we are taking 4 days, right? So this capacity is not possible. We need to increase our capacity so that we can take in more weights into it. We can load more weights, isn't it? Let's say this is our weights array, and let's say we have to ship all the packages in one day. Okay, if this is the case, we will have to choose only one ship, right? We can choose only one ship, and that ship will be sent in that very day, right? In a single day. So for that, what is the capacity that we are going to need? We are supposed to take a capacity that can accommodate all these weights, all these packages, right? So what will be that capacity? That capacity would be the sum of all these weights, right? What is the sum? 5, 9, 14, 20. We need a ship of capacity 20, not 21, because because we are done with 20 only, right? No need to take more than that, isn't it? So what we can infer from this is that from this weights array, in order to load in order to be able to load all the packages, we need at least a capacity of 6, right? And at most, this is the minimum capacity that we need, and at most we can have a capacity of 20. This will be able to accommodate every one of them one by one, not all of them, but at least one, and this can accommodate all of them, right? So what are we getting from this? This is the lower bound of our capacity, and this is the upper bound, and our optimal capacity lies somewhere between 6 and 20, isn't it? So what do we understand from that? We need to increase increase this 6 as well as decrease this 20, our answer lies somewhere in between. We have to reach from from both sides. So what do we understand from that? This is nothing but binary search, isn't it? We have a lower bound, we have a upper bound. What we are going to do, definitely we are going to take a mid of 6 and 20. We are going to see, let's say this mid, let's assume this mid is our capacity. Okay, we will try to accommodate all those, every package into that ship of this mid capacity. Okay, and we will see how many ships we are going to require. Let's say we have been given d days, that is we need to ship our packages within d number of days, and using this capacity of mid, we are able to ship all the packages in x number of days. Okay, x number of days or x number of ships, because each ship will be shipped in each day, right? One ship is taking one day. Okay, now if this number of days is greater than this given number of days, that means it's taking more than we should, right? More than it should. So what does that mean? Our mid is too small, right? That it's not able to accommodate more and more packages into it. In that case, we need to increase our capacity so that it can accommodate more and more packages, right? Otherwise, let's say we took x number of days or x number of ships, and it is lesser than or equals to the given number of days. Okay, that means we took, if we are supposed to deliver within d days, we took less than or equals to d days. That means we are satisfying the condition, right? In that case, what we can try, we will see, okay, if we still decrease our capacity, will we be able to deliver all our packages in time? We can try that, because our task is to minimize the capacity of each ship, right? So what if we can? So we will try that. Okay, so let's say this is the area of our weights, these are the weights of our packages. All right, what is the minimum capacity that we should have? It is 5. And what is the maximum that we should have? It would be the upper bound would be the sum of all these. What is that? It is 15. Let's say the number of days we are supposed to deliver them is 3. Okay, we are supposed to deliver all the packages within 3 days. Okay, now let's try a mid. What is the mid of 15 and 5? It is what? 10. Okay, let's try using this capacity. 1, 2, 3 and 4, they can be loaded into one ship, right? The sum is 10. We can load it in, and then we can load this one, because if we take this 5 with them, it will exceed, right? So how many ships did we require? We require 2 ships, that is 2 days, that is less than 3, right? Okay, we are able to deliver all our packages in time with this. Let's see, if we decrease this, can we still do it? Let's try that. How are we going to do that? We are going to decrease our high. What will be the high? The high would be 9, that is mid minus 1. Okay, for now we will record this 9 in a variable result, say. Okay, that this one gives us an answer. We will now try for a better capacity. So this 9 is the high now. 9 plus 5 is 14. 14 by 2 is 7. So our new capacity is 7. Can we ship all our packages in 7 capacity? Let's try. 1, 2 and 3. We can do that, isn't it? We can load these 3. Then if we take this one, we can load it. We can't take this one, right? It will exceed. So we will take this one and take this one. How many ships? 3 ships. And this one gives us a better answer, right? So we will consider this one, that okay, we have a better answer. We can minimize our capacity and we can still deliver all our packages in time. Okay, can we do better? Can we do better? Let's try that. What will be the new high? Our new high will be 6. Okay, let's take 6. What is the middle? 6 plus 5 is 11. The middle is 5. Okay, let's try with a capacity of 5. 1, 2, 3. No, only 1 and 2. Only 1 and 2 is possible. Okay, one ship. 3, 4. No, we can't take 4. 3 is possible only. Okay, let's take 4. Can we accommodate 5? No, we exceed. Okay, 4. And this remains as it is. So how many ships did we take? We took 4 ships. We took 4 ships means we took 4 days as well, right? So that is not possible. We exceed our time, isn't it? In that case, what we will do, we will increase our low. Increase our low to what? Increase our low to mid plus 1, that is 6. So our low becomes 6. 5 plus 1, let's, what is the new mid? 6 plus 6 is 12, by 2 is 6 only. Let's try with this new mid. Can we accommodate this? 1, yes, we can accommodate. Can we accommodate 2? Yes. 3, yes. 4, no, we exceed. Let's try to accommodate this. Can we? Yes. Can we? No, we stop here. Can we accommodate this one? Yes. This one is the last one which remains. How many ships did we take? We took 1, 2 and 3 ships, right? And we haven't exceeded the given number of days. Now what is the capacity that we took? We took this 6 capacity, this new capacity, right? And it is better. So this is our final. Okay, we will still try to do better. Okay, we'll still try to minimize it. Now if we try to minimize our mid once again, what we will do, we will reduce high, right? High equals to mid minus 1, that is 5, and our condition low less than equals to high will be broken. They would cross each other, right? They should not cross each other, they should stop before crossing each other. So our condition breaks and we finally have our answer. Okay, now that we have our idea that what we are supposed to do, let's try to code this up. Okay, what we are going to need, we are going to need a lower bound, say low, and an upper bound, say high. Let us initialize them with 0 first. Now what is the lower bound going to be? That is going to be the maximum weight. Okay, that maximum weight is going to be the minimum capacity, right? So let's do that. Int w in weights, low is going to be the maximum out of them, low w. And what is going to be high? Our high upper bound is going to be the sum of all the weights, right? That it would be able to accommodate all of them, right? And we will take only one ship. So high plus equals to w. Now we are going to need a result variable, say res equals to what? Let's initially assume it the maximum capacity, that is high. Okay. Now let's start our binary search. While low is less than equals to high, let's compute our mid, that is the capacity, current capacity, high minus low divided by 2. What is this? Assuming mid as our capacity. We will try this mid as our capacity and we will try to ship our packages with this capacity. If say can be shipped what? Can we ship the packages? Let's say this one, the weights, the array, and the mid, that is our capacity, less than equals to say days. We will call this function and it will return the number of days that we took to deliver our packages if our capacity of a ship is mid. Okay, if we can we will try for a better capacity, a lower capacity. So let's say mid minus 1. Okay, and let's keep this capacity recorded, right? This can be our answer. So let's keep it with ourselves. If we find a better solution, if we find a better capacity, we will update the result. Otherwise, if we took more number of days, that means our capacity is too low. So in that case, we will increase our lower bound, that is mid plus 1. Fine. And at the end, we will return our result. Now let's write our can be shipped method. The weights and the capacity, that is our mid. Okay, we are at least going to need one ship. Let's initialize it with 1 and let's have a current capacity equals to 0. In this current capacity, we will load each weight one by one. Okay, all right. For say int w in weights, let's put it in our capacity, current ship plus equals to w. Okay, if our current capacity exceeds our capacity that we are supposed to have, the maximum one, like this is our capacity, right? This is our maximum capacity our ship can handle. So we can't exceed that. If we exceed, what we are going to do, we are going to need more ship, right? And in that new ship, we will put this weight into that new ship. All right, because when we took this ship, when we took this package, our capacity exceeded, right? So we won't keep it in that previous ship, we will put this in the new ship. So we will reset this current capacity for our new ship. Okay, at the end we will return the number of ships that we took. That is nothing but the number of days, isn't it? Let's try to run it. So what is our time and space complexity? Initially we run a for loop in weights to calculate our lower and upper bound. That's a big O of n, right? Then we do binary search on our search space. Let's assume our search space is say m. Okay, so that is going to take log of m. Now with each binary search, with each iteration, we call our can be shipped method that takes a big O of n time, right? We in this we iterate over our weights array, so that is into n, right? We can write this as n log m, right? So our time complexity is big O of n log m. And what is the space? It is constant. We are not using any extra space, right? So yeah, this is our solution. I hope all of you understood. I tried my best to make it clear. All right, so if you like this video, hit the like button, share this video to your friends, and subscribe to my channel, and I will see you in the next video. Bye bye.